Evening, this is Santosh, and today we are going to discuss about the next lecture of Agentic AI. So let's start. So we are going to discuss how MAS works in a scenario. So we have a detection, collaboration, adaptation, and execution. So demand prediction agents detect the surge in demand early. And then we have a collaboration. Supplier agents identify alternate vendors. Logistic agents reroute trucks to priority regions. Inventory agents shift stocks between the warehouses. So these are the collaborations. And in multi-agent system, we are going to discuss how things going with that respective. So in next we have a adaptation and execution. So agents adjust plan dynamically. So they are goal specific and task specific oriented agents are there. They plan dynamically and avoid cascading delay. So if you given a particular agent, I have to execute particular task in this and that particular duration, so they will do in that particular way and particular duration. Execution, the second is execution. So they execute independently and the system implements the optimized supply chain strategy autonomously. So process workflow of a multi-agent system. We have a process workflow of a multi-agent systems. So we have four things: real-time monitoring, agent collaborations, dynamic optimization, execution, and feedback. So in real-time monitoring, Internet of Things enabled sensor provide live updates on inventory, transportation, and demand. So this multi-agent system going to transform the transportation system, demand and supply, inventory. So these things are going to be changed in multi-agent system. Agent collaboration, like for example, we have a three agent and they are doing three different tasks simultaneously. So and they are sharing the data through centralized communication platform, so they collaborate and they perform the specific task with the help of other agent as well. And dynamic optimization is the third one. So suppliers expedite shipments and warehouses relocate stocks. So these things are going to happen in a dynamic optimizations. Routes are recalculated for efficiency. For example, I have to go from particular A point to B point, and there are three ways to go from the point A to point B. So this will calculate a best route, shortest route, time saving routes, and traffic. There are less traffic, so it will be calculate and select that particular route for the efficiency. The next is execution and feedback. Agents implement decision and refine strategies based on the feedback. Benefit of the multi-agent system. So, what is the benefit of multi-agent system? Separation of concern ensures that different aspects of AI functionality are distinct and can be developed, maintained, and updated independently. So modular system is there, like we have a different module, facilitate the creation of reusable independent components that can be easily integrated and adapted. Scalability, so they can scale. With the help of multi-agent system, we can scale. Supports the ability to handle growing workloads and expanding user bases without compromising performance. Graceful recovery enables the system to recover smoothly from the failures or disruptions, minimizing downtime and ensuring continuous operations. Flexibility and agility provides the capability to adapt quickly to changing requirement and business needs, improving responsiveness to the new challenges. So we have the challenges and mitigation strategies of multi-agent system. What is the challenges? We have a complex system design. For example, in description can become difficult to the design due to the inter-agent communication and dependency. Mitigation strategy: use modular agent frameworks to simplify agent development and deployment. Interoperability: integrating agent with existing ERP, WMS, TMS system can be difficult. Adopt standardized API and data format from the seamless integration. What is the data security in that particular perspective? So, sensitive data, we have a sensitive data in banking domain and finance domain. We have a sensitive data, so that sensitive data shared between the agent and external vendors can be vulnerable to breach. So data should be protected with the help of these agents. And how can we do that? We give the specific task, security related tasks to execute for a particular agent which are very secure, or cryptography implemented agent. Cryptography is the way we can secure the data. And implement end-to-end encryption, secure authentication protocol. We have encryption as well as we have a protocol, authentication protocol to traceability and conflict resolution. Agent may have competing priorities, logistic versus inventory, leading to insufficient. Introduce a decision-making agent with conflict resolution algorithm to mediate disputes. Scalability: scaling agents for a large system can strain computational resources and increase latency. Use edge computing and the cloud infrastructure for the distributed processing and scalability. Cost of implementation: whenever we go for the implementation, high initial investment in the developing and deploying multi-agent system. Start with the critical areas first. Use incremental deployment and open source framework to cut cost. So this is the way. And slow development. Developing a cohesive MAS may take longer, especially without a clear requirement. So whenever we are going to handle a large project, so we divide into the different modules, and it is very very important to clear the requirement. Whenever we give the clear requirement, 50% work has done. So requirement should be very clear. Balance granularity with a modular design principle to streamline development. Sophisticated orchestrations requires advanced orchestrations to utilize agent capability efficiently. Design centralized or the distributions coaches or orchestrators without AI algorithm to optimize coordination. Orchestrating agentic AI system. In this section, we take a closer look at how to orchestrate multi-agent system MAS. We short form multi-agent system we call as a MAS, so that different autonomous agent can work together smoothly. They can coordinate with each other. They can share the data algorithm. Based on data and algorithm, they can perform a specific task, and with coordination they give the output. We will dive into the challenges of managing complex system. Have communication between the agents play a key role, and the impact of that task allocation on efficiency. This section will include importance of orchestrations, common challenges, and role of communication and agent registries. Task breakdown, planning, and verification stops for a successful implementation. So we have a diagram related to AI, automation, communications, technology, networking, big data, and robotics. So this is a flow or a diagram of that particular AI related things. Orchestrator in action. So enterprise use cases, data science and analytics, process automation, supply chain management, research analysis, QA automation. So in Orchestrator, plan, execute and verify. Agent registry. What is the registry? Registry is a place where we can keep the things in a very protected way, whether it is a hardware or software related registry. So we have a web agent, API agent, text images analysis agent, contextual search agent, data science agent, compliance agent, and agent software development kit. So data, tool system, models, and frameworks. Data, enterprise DB with a variety data formats, tool system support over a hundred software integration based on the OpenAI spec models from the GFM like a Gemini, Cloud, GPT-4 to open source and custom models. Framework, agent build using third party framework. So they basically use the third party. What is the third party? Third party is specific for the API application programming interface by which we can uh, interact with that particular framework. So building on a fine tuning and prompt tuning of the GFM and custom large language model. The orchestration of the multi-agent system is a crucial due to the need for the cohesive functionality among autonomously operating agents within a shared environment. So they share the data. Agents share the data along with that. They share the environment with the help of that they perform tasks. Uncoordinated multi-agent system face significant challenges. So, what is the disadvantage in multi-agent system? If they are not coordinated well, they may change. They face the challenges. With the failure rate for the digital transformation is estimated at the 70 to 80%. So, reflecting similar struggle in achieving objective due to the lack of collaboration. So collaboration is a very important in the multi-agent system. This coordination ensures that distributed agents, so they are the not specific for the location or system or the program. They are the distributed, each with the specific roles and capabilities, efficiently collaborate towards the collective goals without the redundancy or the conflicted actions. Orchestration is vital for the synchronizing agent activities, managing inter-agent communication and optimizing the resource allocations, thereby enhancing the system overall performance and effectiveness. Without effective orchestration, the agents may operate in the silos, have different goals and objectives, leading to inefficiency, conflict, and the suboptimal outcomes without a proper orchestration mechanism. The whole purpose and advantage of MAS is defeated. Challenges of orchestrating complex agentic systems. So first one is communication and coordination. Ensuring seamless communication among the diverse agents can be difficult due to the differences in the functionality and sophistications. Interoperability issues arise when the agents are designed with the varying technologies or standards. Developing a uniform protocol for the interaction is often essential, but it can be a complex to implement and required collaboration within the community. So conflict management is there. Agent operate autonomously, which can lead to conflict arising from the overlapping objectives, competitions for the resources, or the differing priorities. Resolving these conflicts without human intervention requires effective automated mechanism. Choosing the right agent when multiple agents with the desired capabilities are available. A selection process is needed to ensure the most suitable agent is chosen based on the context, efficiency, and resource availabilities. Scalability. Orchestrating large-scale systems with a hundred or thousand of agents present logistical challenges. A robust infrastructure and efficient resource allocation algorithm are necessary to support dynamic scaling. The system must be designed to accommodate the additions or the removal of agents without disrupting performance. Reliability and the fault tolerance. Maintaining system reliability is critical, particularly when dealing with the partial failures. A failure in one agent should not jeopardize the overall system functionality or performance, necessitating advanced fault tolerance mechanism. These challenges highlights the complexity involved in orchestrating multi-agent system requiring a careful balance of technical strategies and collaborative efforts. Key aspect of the orchestrating multi-agent system communication mechanism between agents. Efficient communication is a fundamental to the success of any multi-agent system, enabling agents to exchange informations, negotiate tasks, and collaborate to achieve shared objectives. To facilitate this communication mechanism relies on well-defined protocols and languages that ensures high interoperability and minimize the potential for misunderstanding or miscommunication. Common communication protocols include point-to-point messaging and publish subscribe model. Facilitate direct message exchanges between the agents for the targeted communication. Enable asynchronous communication ideal for the large-scale distributed systems. These communication models should support various communicative acts such as the request, assertions, and queries, which simplify decision making and problem solving processes. So we have protocols like the Model Context Protocol and the OpenAI Function Calling specification offer standardized frameworks for the information exchange, fostering a shared understanding among agents. While these initiatives are in their early stage, further development is needed. The choice of communication model, so we have a model, different type of model is there, and we choose to communicate, and language has a significant impact on the overall efficiency, reliability, and the success of agent interaction within the system. So agent registry and exposing the capabilities of the agents. An agent registries serve as the central directory within a multi-agent system, cataloging available agents and outlining their unique capabilities and services. These registries enables dynamic discovery and interaction among the agents, allowing them to be accessed based on the specific requirements on or collaborative needs. Specifying agent capabilities evolves, detailing roles, functionalities, resource requirements, and constraints, which are the vital for the effective task allocation and coordination. The registry mechanism task matchmaking by aligning agent capabilities with task demands. Improving workflow management, it also ensures the seamless introductions of new agents while maintaining the operation of legacy system. Comprehensive agent capability specification boost interoperability, simplify integration, and ensures accurate task assignment by the orchestrator. Planning and task breakdown for the different agent. So we divide the different task for a different agent. Effective planning and task breakdown are the crucial function for any orchestrator for the coordinating agent activity efficiently across the multi-agent system. And how can we do that? The planning process begins with the understanding the overarching objective and identifying the task required to achieve them. Each task is then decomposed into a smaller, manageable subtask which can be allocated to the agent based on their capabilities, availability, and current workload. So we have a sophisticated algorithm often support this distribution process considering agent strength, task dependencies, and completions headlines. This ensures tasks are assigned to the most suitable agent, optimizing the system, collective intelligence, and the performance. By executing tasks in a parallel across multiple agents, when the properly planned and broken down, the system enhances efficiency, reduces bottlenecks, and accelerates project completion times. Verification of the desk of the task done by the different agent. Whenever we perform the different task by different agent, then we will verify them whether it is correct or not, they executed correctly or not. So verifying the output of the task performed by the different agent is a vital to maintaining system reliability and quality assurance within a multi-agent system. This verification process involves cross-checking task completions against the predefined success criteria of performance metrics, ensuring that the output align with the expected results. Depending on the system complexity, verification can be automated using the built-in evaluators or the required human oversight in the ambiguous scenarios. Feedback loops are the integral to verification, enabling the system to learn from the mistakes and refine future task execution strategies. The reliability assured by the rigorous verification processes bolster trustworthiness within the system, essential for the enterprise system and workflow. Execution pattern from the different workflow. Execution pattern define the structured sequences and methodology for the completing tasks across various workflows within the multi-agent system. Common execution pattern includes sequential, parallel, and iterative patterns, each offering a distinct approach to managing task flow. Sequential execution is the appropriate for the workflows where the task must follow a linear progressions with each task dependent on the completion of its predecessor. In the contrast, parallel execution allow multiple tasks to run simultaneously, making it ideal for the independent or loosely coupled tasks that can be executed concurrently. Iterative patterns are useful in the situation that require repeated cycles or the tasks that need refinement through the multiple rounds, allowing models to process and improve their output. So, scenario multi-agent system for the sales forecasting in the Excel. So imagine a retail company aiming to predict sales. Whenever we have good sales in any company, sales is very required, by which we can get the money and we can make profit from that particular way. For the next quarter, optimize inventory and generate actionable reports. The company deploys a multi-agent system where the specialized agent collaborates seamlessly, each contributing a distinct role to ensure efficient and accurate results. The orchestration of these agents ensure a synchronized workflow that deliver optimal outcomes. Role of the agents. Each agent is a system play a specific role contributing to the overall goal. Data collection agent, data process agent, sales prediction agent. So we have a data collection agent like role gathers sales and customer data from the various sources. Point of the sales system, customer interactions, online platform. Example, collects sales figures, customer they they perform the collections sales figure based on the customer demographic and the transactions log. Based on the transactions log, they find out. And data processing agent. Once we collect the data, we will process the data through this particular agent. We have a different type of agent. Once we get the data through one agent, now we are going to the process the data through the other agent, cleans, transform and the processes raw data into the usual format, removes irrelevant data or unwanted data. They remove and handle missing values and standardize format. Now the third one is the sales prediction agent. In this agent, what is the role of that particular agent? They uses machine learning models to forecast sales based on the historical data. Example, predict next quarter sales by region, store and product category. Orchestrator verification agent. What is the role? Oversees workflow, validate data integrity, and ensures forecast accuracy. Example, cross-check prediction against historical trend and predefined success criteria. The last one is a report generation agent. What is the role of that particular agent? Creates actionable reports and the dashboards for the business leaders. Example, produces sales forecast with visualization and key performance indicators. How it's all work together. The multi-agent system operates through a structured and orchestrated flow, ensuring efficiency and accuracy. Data collection is there. Data collection agent gather a raw data. So they collect the data. So that particular agent perform the data collection through the different gathering raw data mode from various sources, such as we have a thousand of record of the transaction customer record, and that particular record is stored in the customer database. So that agent particular agent collect the data from the database, and they all work together with a different multi-agent system. The here we are going to discuss in multi-agent perspective, data processing and sales prediction. So they process the data, agent process the data, clean and format the data for the predictive analysis. They based the analysis based on the data whatever they collect. Sales prediction agent generate the forecast, identify trends and the patterns. Orchestrations verifications. Agent validate predictions, ensuring alignment with the business rules and historical data. Based on the historical data, they do that one. Report generation. The report generation agent creates dashboards and reports with the actionable insights. Execution flow. Sequential execution, parallel execution, and iterative execution. Sequential execution. What is sequential execution? They perform tasks by sequence. They collect the data. Second, they process the data. Third, they predict the sales based on data. And then they verify the data whether it is correct or not. And last, they generate the reports. Parallel execution, they perform the sales and report generation simultaneously. They execute the task based on data or with the help of agent parallelly and combine the result. Iterative. They iterate things for the better result, forecast verification and feedback like that. Final outcome and benefit. By orchestrating the mm, collaboration of specialized agents, the system delivers robust, actionable sales forecasts that enhance decision making. The orchestration ensures that each agent contributes effectively without redundancy or conflict. Efficiency and scalability, accuracy and orchestration is there. Efficiency automates data collection, processing, and reporting, reducing manual work and time spent on repetitive tasks. Scalability handle vast amount of the data across multiple regions, stores, and the product lines. Accuracy, iterative refinement of the predictions ensure consistency, reliable forecast. Ensure smooth collaboration between the agent, minimizing errors and maximizing output quality. Practical insight for the orchestration in multi-agent system. Centralized control, feedback loops, error mitigation, scalability management. The orchestration verification agent act as the central node, coordinating our task and ensuring data flows smoothly between the agents. Feedback loops, iterative cycles improve predictions accuracy and adapt to the changing conditions or new data. Error mitigations. Validation steps prevent inaccurate or incomplete data from the propagating through the system. Scalability management. Agents can be scaled independently, allowing the system to adapt to increased data volumes or the additional business needs. Practical steps for the organization's workflows and implementation strategies. Balance of autonomy and human oversight. Establishing rigorous benchmarks, explainable AI decisions, exhaustive validation and testing procedures, ensuring comprehensive data management practices. These are the basic things. Deploying Agent AI system within an ent- enterprise environment necessitate adheres to the set of technical rigorous best practices designed to the harness their full potential. These practices ensures the seamless integrations and optimal functionality of agentic AI, which is characterized by its ability to autonomously manage complex and the dynamic workflows. Balance of autonomy and human oversights. Incorporating agentic AI into the business operations required a balanced approach where AI autonomy is the completed by the human oversight. This interplay ensures that the AI-driven processes align with the strategic objectives of the organization. Human interaction in the validation AI output to the critical to maintaining alignment with the corporate ethical standards and objectives, thus mitigating potential risk associated with the AI autonomous decision making. Establishing a rigorous benchmark defining precise quantifiable performance metrics is essential for the accessing the capabilities of agentic AI systems. These metrics act as a benchmark to the GOG AI effectiveness, identifying areas in the need of improvement. This in terms allows for the continuous refinement of AI system to better meet evolving corporate demands. Explainable AI decision, ensuring transparency and understanding in the AI decision making process is essential for the fostering trust and the compliance. Organizations must implement systems that provide insights into the reasonable behind AI decision. This transparency is vital, particularly in highly regulated sectors to meet compliance requirement and the fortify stockholder trust. Exhaustive validation and testing procedures. We have that as well. Through testing, Whenever we finish the development part, we go through the testing part. Is the cornerstones of the successful deployment AI system. Whenever we deploy AI system or any application, we go through the testing. Before full deployment, agentic AI must be subjected to extensive testing because testing is very important. Without testing, any application cannot survive in the real time. So testing is must. Regimes to uncover and address potential vulnerabilities. This meticulous testing ensures that the system operates as expected and anticipated issues that might affect the optimal performance. Ensuring comprehensive data management practices, instituting a robust framework for the data management is integral to the accountable deployment of agentic AI. This involves detailed monitoring of the data interactions and the application of the metadata to ensure actions taken by AI are the transparent and verifiable. Such governance safeguards data integrity and facilitates compliance with industry standard. By adhering to these technically sound practices, enterprises can effectively deploy agentic AI system, thereby optimizing workflows and the fostering trust in the agentic AI system. Emergence leader in autonomous multi-agent orchestrations for the enterprise. So Emergence AI is the collaborating with the Amazon Web Services, NVIDIA, Skyfire, Scratch. These are the things. So leaders in the autonomous multi-agent orchestration for an enterprise. So emergence AI is the transforming enterprise operations with multi-agent orchestrations. So your readiness for the agentic AI. This section dives into the essential of the bringing agentic AI to the life. We explore the foundational element that drives success, evaluate industry specific readiness, and outline strategies to overcome challenges at every stage of adoptions. Foundational element to start implementing data readiness, technological infrastructure, organizational alignment and strategies, a skilled workforce, and cultural and ethical things. Organizations maturity and readiness assessment framework. As the demand for the AI grows, many organizations are exploring agentic AI, an advanced form of AI that drives automated decision making and enhances operational efficiency. However, transitioning to this technology is not a one size fits all approach. Organizations must carefully evaluate their readiness as adopting agentic AI depends on the various maturity levels. For some, it may be the right time to dive into the agentic AI, while for other, the focus should be on strengthening foundational element before taking that step. So in next slide, we will discuss the next lecture. Till that time, thank you for watching. Goodbye. If you like this video, you can like, share, and subscribe. Thank you for watching. Bye.